by which you try to use data in order to so if you remember, you have got your data set, and this data set, what are the processes in order for you to come with an app? What do you do? Can you remember anything? Anyone? Process it. What do you mean by processes? How do you process it? Pre-process it. How do you propose a pre-process data set? I mean, what are the steps? Let's say that you have got a fantastic idea for an app. What do you do? How are you going to go about it? Come on, I know it's early in the morning, and I've let you down by not making you sleep at the right time, but let me believe you me, I'm up since 6 o'clock. So, anyone? How would you go about it? I mean, after the lecture of Dave, you've got some idea what you should be doing with the open data. Anyone? Come on, talk to me. Just been running all the way from the... okay. So, effectively, we have our data sets. And this data set, we want to have an app. Let's say mobile app. So there is a process which you use some data set to produce an app. Let's say, come to the example of something like Uber. What happens with Uber? Has anybody got any idea how the process works with Uber? No? Oh, Lord, lively. So, how do you actually book a taxi on Uber? Yeah?
I think on the app you can see the taxis around you, and you click on which one's next to you, and you got to accept or reject.
Okay, that's right. So, I mean, where does the taxi know what is your mobile that it's you that's booking a journey?
You go and have an account on it, and it uses GPS.
Yeah, but I mean, before that, presumably you have to go to some sort of web server, register, get an email, get your unique ID that it can relate to you, and then when you actually get back to the app, it can find out what's happening. So today, the most important thing that we need to consider if you have to actually start working on an app is about, if you remember this diagram that David also took out the wisdom at the top. So, what does this diagram tell you? What do you understand from that? So what is the bottom line and what is the top one? So you collect the data, you use the data, you try to make it as an information. Data by itself hasn't got any value. Okay? Data by itself hasn't got any value. What you need to do is you need to understand something. I mean, the whole of this concept of data science has got two purposes, and I told you at the first lecture. You either try to solve a problem or tell a narrative. So let's stick to the scenario that you want to tell a narrative. You want to provide some service which provides an app which provides a service. The service is either sell something or tell something. Okay? So Booking.com. Booking.com tells you a narrative. Tells you a narrative about these hotels that you might need to have with certain range of price within certain localities with certain rates. It's telling you a narrative. and then picks up a number of candidates which are maybe from the price all the way from top to the bottom, or the relevance, or what is going to be the search priority, that it tells you that. So the data at the bottom is the information that by itself it doesn't mean anything. These are the links, URLs to that particular sort of content. And this information comes to this sort of like a web service. Through that, you would be able to actually extract your information, and then you would be more knowledgeable to say that if you want to go to Barcelona, if you are at certain parts of town, maybe you can find that particular hotel which is fitting your pocket. So you extract the knowledge based on a simple data. But there is a process to that. And today, what I'm going to tell you about is how you would actually extract the data and make it the knowledge. So this is what we call data wrangling. Means that the data that you have got, I mean, these are sort of like data sets. And data sets are information, let's say it's about a hotel, or it's about a restaurant, or it's about a car. Each individual data set refers to one particular player in your mosaic. Okay? So you have got various different data sets. These data sets, how do you go about collecting them? Where do you get them from? How do you get the data?
You make a API call, make a request to the data.
Make a request. What are other options?
From a database.
From database. What else? Come on, who was this? Speak up. You can also create the content, can't you? You can also create the data set. So if somebody making the class list of this particular class, COM6218, 6214, someone at the student office makes this data set by collecting people, taking your pathways, and then this is a data set. Okay? So the person who sits in the student office is actually making a data set. When you are registering at the university, you are making your own data set. You're providing your own profile. Okay? And then this profile provides the basis for everything else that you come on top of it. Okay. So remember about this pyramid. In order to actually process this or go through this process, what you need to do is you need to collect the data, and the data that you have got can be different formats, can be different files, you can have different, coming from there, various different things. Okay? Before you actually can do anything with the data, you have to clean it. You have to make it in a standard that you are able to use it. So to do that, cleaning the data is probably the most cumbersome, but the most important process throughout this course of action. Okay? So, so you collect your data and then clean it. I'll talk about that in a minute. And then, what is the purpose of visualization when you try to visualize the data? I think Dave mentioned that, and I briefly also mentioned that at my introduction, actually at the second lecture. What's the purpose of visualizing data? Yeah?
Make it easy to learn.
To learn? What do you mean to learn?
Well, how about making it easier to learn a concept?
To understand it.
Yes.
So, if you remember, there were things that we put up. So if you have got 1, 2, 3, 4, 6, 7, and then a lot of numbers. If you are looking for the number 5, it's very difficult to see it in an array, but if you just change it to the color stands out by itself. So if you have got huge big data sets, you have to be able to, at least at high level, be able to get some gist of this. So when you are looking at, let's say, satellite data, that is looking at the environmental changes, let's say looking at the pollution somewhere in London, okay? The level of pollution, how would they actually represent it? You look at what is called as a heat map, okay? The heat map is just effectively is a color scheme by which a grayscale scheme by which normally things are very, very concentrated. They put it with a higher sort of rank of this, normally red, and the ones that are less, they put it as blue. I don't know why, but that is actually, if you're a physicist, you would know that blue is much higher energy than red, but it doesn't matter. But what I'm saying is, that is how they actually use what is called as a heat map. And this heat map is just when you're actually looking at this simple picture, and you are trying to sort of look at these differences. The computer does not make any difference, but we try to understand what is called as partitioning the data and segmentation. So when you look at the picture through this heat map, you would be able to distinguish what is different between its neighboring area. Okay, so the visualization is the way that can better explain your data set. And once you can better explain or better understand your data set, then you start analyzing it. So, let's say you have been working for the Home Office, and they were asking you to produce maybe some sort of study for car crimes, car burglaries, or maybe different type of crimes that happen in Southampton. How would you go and do that? You just get all the data sets, maybe from open police data sets, from the Home Office, from serious crime. All this data are open. So you can actually just put that on top of the map, sort of within certain radius of Southampton. And then you will be able to sort of like annotate different colors for different type of crimes, or what is the intensity of it at different places. And then would be able to give you a snapshot of what it is. So, let's say you produce that, and an insurance company comes and have a look at your app, and then say, oh, brilliant, we have got an app that very quickly we would be able to see which areas in Southampton are more immune to crime. So obviously what is going to happen is the insurance premium for car insurance is going to go up. So this is the logical process by which you have to think about. So there are two ways of going about it. You have to think about top to bottom if you are looking at a application or a scenario. So if you want to make an app, if you have got an idea for a brilliant app, this app, whatever it is, this has got these common denominator. So you all have to understand all these processes. Because if any of these won't function, then your app would fail. I mean, your app might still fail because it hasn't got the right user acceptance, but at least it won't fail because its fundamental structures are not well thought of. Okay? So effectively, the way that you have to go about creating the content is that you would have to acquire, and if you are looking at various different ways of looking at this metadata, you have to parse, you have to filter, you have to mine, you have to represent, you have to refine, and you have to interact. So I'm not going to go and talk about this prediction. I mean, I think I've got some of my students in this group from the GDP2. Is anybody there? Oh, anyway, for example, another group of my students this year, they came with an app, which this app is actually a platform. It makes a prediction of the Premier football game. So it looks at all the data. It actually feeds in the data as a live stream into the process, and then it makes a prediction, and then it comes out as an app, as a mobile app or as a web app. So if you are actually looking at a game between Newcastle and I don't know, Bournemouth, depending on the set of data that you have and all the various different parameters that you put to analyze this process, it would come up with some sort of a prediction. I think if any of them, I don't think they're around, but maybe I can ask them to show you this. So this is really a typical type of application that you can make, but obviously in this application, the core is on the engine which does the prediction. Whereas something like Uber is a mindless platform. It just matches A to B. It matches certain passengers to certain distance. So these are by far much simpler apps that you can define. But all these apps and all the services have to go through this common denominator that you have to clean them, you have to be able to take away the reputation and stuff like that. And in order to make the data in a way that you want to use it. So, what I'm going to do actually next week, Doretta is going to be working with you at 9 o'clock on Monday, so you will be able to start working on the data cleaning process. Today, I'm just going to introduce you to these ideas. So, in order for you to be able to use the data, especially open data, or any type of data that you get, you have to be able to validate and clean it and explore it to see at all this is the sort of data that you want to use. So, who has come across the terminology data mining? Okay, what does data mining mean?
Extracting some useful information from all.
Okay, so where does the terminology mining comes from? Does anybody know? Yeah?
It offers the same concept as real life, like a real life instruction of mining it, which is going to dig up, you're looking for something and you're digging up everything pretty much.
Absolutely. So if you are trying to, if you are at a gold mine, and the gold mine, what it is, it's a piece of land which some parts of the dirt is mixed, or the rocks, would mix with a different type of metal, which is gold. So I think in the old days in California, they used to call this gold rush. It was that they were buying this piece of land, and then they were mining it. So they were going through all the dirt, they were washing it, and all the gold would stand out. So this is the same sort of concept. What you do now, you get a lot of information, a lot of data. But this data are not what you really want. You want just the bits that are relevant to you. And in order to do that, you have to first identify it. And then you should be able to clean it and be able to process it in order to extract it. And put it, and then sort of in the case of the gold, make gold bullion or jewelry or whatever it is. So this is the same for in the case of the data set. What we have got is we have to look at the data set and then be able to extract things which are common. For example, errors. Okay? And let's say that you have got a data set which comes from the Department from the airline, from American Airlines, okay? So, the Americans use different type of data format as the British, okay? They actually use for example, they say, in Britain, if you say 20 of 2, oh no, well, that's not really good. Let's say, what does that mean? Yes, whereas in America, it is 2nd of May 2017. Okay? This is the way that just Americans use the date format. So if you want to actually try to use it, you should be able to clean that and make it a standard by which you want to use. Okay? So you have to validate this data, and also there is for example, this is color, and this is color. One is American, the other one is British, is English. Okay? So there are these discrepancies also to the data. Before actually you can make sense of the data, you should be able to do that. Okay? So in order to do it, what you use is you have to look at the problem. So one of the things that I told you about is the date validation, and especially with American data sets and in combination with the British data set. This is a very, very important thing, because I mean clearly if you are thinking of developing a very clever app, go to Silicon Valley and sit next to Mark Zuckerberg, you should be able to make sure that the data you're providing is American data validated, and it's not British. You see, the devil is in the details. And when you actually try to you try to make an app, it's important that you understand where you're going from. Where you're coming from, sorry. So there's also a multiple representation. And for example, if you have got something like VP, what does that stand? Vice President. But if somebody actually writes it as Vice President, then the software should be able to distinguish between these two. Okay? So it's really quite cumbersome. But luckily, you've got tools like Google Refine, or they call it Open Refine, which look at the various different problems that you are facing. For example, numerical scales. I mean, the numerical scales are also very important. I mean, I know that, for example, NASA lost a huge amount of money on one of its missions because rather than measuring things in meter, they used imperial measurements. And then when you think about, you're just chalking out something like just trying to predict a mid distance by an object or a heavenly body, and then you use different scales. That is also can be quite disastrous. Okay? Yeah?
I was going to say, not only that, they also, I remember there was one time where they were supplied parts from Europe, and they supplied I think there was this Italian group that supplied the parts to the Americans using the meters, and they also used the European type of plastic.
Yeah, I mean, they use that is absolutely typical. I mean, empirical, especially, let's say, the Anglo-American type languages in America, in the UK, in Canada, well, not so much in Canada, but in Australia and places like that, they still use empirical scales, and everybody else uses meter. And of course, there are different types of scales that you use, but what I'm saying is, if you are inherited as a data set, you can't pass a judgment on that. You should be able to transform it into sort of thing that you can make use of it. Okay? You can't really judge a data set. A data set is there, it's open for you to use. But you should be able to have enough insight and look for the problem in order to avoid any type of clash within the data set. So obviously the spelling error is also a huge factor in order to get your data set. So if you want to really make sure that you are going to use that data set, you have to apply real thorough cleaning process. I mean, what is also particularly important is if you are, for example, trying to visualize the data set. And if you go back to what I said about these heat maps, and these heat maps are if the data is not accurate, then obviously you're projecting completely different predictions. And that can be quite significant. So what I have got here is I have got two sets of data, which I'm going to put up all this transparency on the module website. That you have got two sets of data, and this data are going to be used by you for next week, so you can work with the Rota to actually understand how you can clean the data. Okay. So to do that, what I'm going to do is I'm going to talk about, actually, I'll see how much I'm going to go today. If you are short of time, I will start with the rest of this tomorrow. So rest assured, you won't be sort of missing out on the content of what I teach you. So the set of data that you want to use are the data processing tools. So the data processing tool that you need to look at for this particular exercise are Google OpenRefine. And what you do is you download that onto your devices. And there's another one called Open Data Soft. Then, obviously, how many of you have come across these with GitHub and CCAN and GitHub? Okay, good. CCAN? Anybody else come across CCAN? Okay. Then there's also the data analytics. How many of you have come across data analytics tools? Okay, what have you come across? Hadoop. Hadoop, okay. What do you understand from Hadoop?
It uses MapReduce, which was created by Google.
Well, original idea, yes.
Yeah, it uses two-step processing. Map function and review function.
Okay, I mean, what is...
But what with key values?
Okay, so I'm going to talk about that later on. Has anybody come across TensorFlow? Yeah? Oh, okay. Okay, good. So, what else with TensorFlow?
Deep learning.
Deep learning. Okay. Right. So, some of you have presumably done machine learning or come from that pathway, don't you? So probably you are introduced to it. That's very good. Okay, I mean, the reason I'm telling you this is just, these arrows I showed you, so these are very different processes that you have to learn before you actually can come with an application. But luckily, there are already a lot of black boxes available that you can put in your data and then understand and then get what you want. But obviously you have to understand what does this box does and where is the shortcomings. For example, with Google OpenRefine, it uses a process by which you can. Oh, I think we should be leaving soon. Sorry. No, it's okay. I will be. What I think I do is I'll carry on with the rest of this tomorrow, and then what I would do is I'll put up this lecture notes tomorrow afternoon on the website, so you can sort of go through the data set, and next Monday you would be doing some sort of practical work with the result and things like that data set. And I do apologize about the